Hello my dear friends, now I am going to explain you chapter number 6. The name of the chapter number 6 is infinite series. In this chapter we will discuss about how to uh, differentiate of an infinite series. Before going to start infinite series, just I want to tell you as introduction part that in science and engineering, we often write functions as a infinite polynomial. As you know that one polynomial means any terminology which is written as like that one. If I have like that one mathematical term 1 plus x square plus x power 3 plus and so on plus x to the power n plus and so on, then we can abbreviate it, we can write it as 1 over 1 minus x. Condition is that x is less than or equal to 1. It means that one we can write this one also as 1 minus x to the power minus 1 is equal to 1 plus x square plus x power 3 plus and so on. This is called infinite series because of see that one after x to the power n plus and so on means dotted term means it will not finish up to any term. So that's why it is called infinite series. Now, the second thing is power series. If any mathematical term which is given as like starting from n is equal to 0 to n in infinity, an x to the power n, where an and xn are the numbers, they are as used coefficient of the series, then that type of terminology is called power series. Maybe sometimes it is written as like that one, or sometimes maybe it will start at n is equal to 1 also. So this is called power series. Power series means why it is called power series, because of that value of the n value is given in terms of power. So that's why it is called power. The most important point is that in power series, this is very important point. In power series, a power series is a polynomial of infinite degree. That means there is no degree of that one because of it mentioned as x to the power n plus and so on. So that's why it is called power series, and the polynomial for that one, degree of the polynomial of that one is infinite. Now, on the basis of that one, I just want to explain you few questions from the handout which is given as differentiation of power series. Differentiation of power series. So first thing is differentiation of power series. Differentiation of power series means how to differentiate this type of series if it is given as. So what we have to do, if fx function is given as power series as from summation from n is equal to 0 to infinite an into x to the power n, then see that we can expand as writing n is equal to 0, 1, 2, 3 and so on like that one. Picking n is equal to 0, it is a naught x to the power 0 plus a1 x to the power n 1 plus a2 x to the power 2 plus a3 x to the power 3 plus and so on. What we have to do, if I want to differentiate this one, that means if I want to differentiate this power series, what we have to do, just differentiate both sides. D dx of fx is equal to, we can say that d dx of a naught into x to the power n, x to the power 0 is 1 plus a1 d dx of x plus a2 d dx of x square plus a3 d dx of x power 3 plus and so on. So when you differentiate, it will give us d dx of fx means f dash x is equal to d dx of a naught, that means 0, plus a1 d dx of x is 1 plus a2 d dx of x square is 2x plus a3 d dx of x power 3 means 3x square plus and so on. This is the differentiation of the power series when series is given as any is equal to 0 to infinity summation a and this one. So that we can say that directly the differentiation of the power series is this one or summation from n is equal to 1 to infinity a naught an into n into x to the power n minus 1 into n into x to the power n minus 1. This one. Or if you want to check that, if you put n is equal to 1, this is a1 into 1 x to the power 0. So this series will come, n is equal to 2a2, this series will come. So we can write this one as summation form like that one. So in short way, just I want to tell you that if power series is given as n equal to 0 to infinite an x to the power n, if you want to write like that, or if you want to directly write that differentiation of that one f dash x, just write this one from n is equal to 1, change from 0, if it is 0 then change 1, infinite n into an into x to the power n minus 1. Why? Because d dx of x to the power n is n into x to the power n minus 1. Using this one, when you differentiate this part, it will come n into x to the power n minus 1. So this is the answer of that power series by using differentiation. That means differentiation of power series. Differentiation of power series. Now I am going to pick another question that find differentiation of f dash x of fx function is given as power function, power series from n is equal to 0 to infinity x plus 5 to the power n. So what we have to do? Just nothing. Solution of that one is differentiation of that. That means d dx of fx is equal to summation from n is equal to 0 to infinity d dx of x plus 5 to the power n. What you have to do when you try to differentiate, differentiation of this one, we can say f dash x is equal to differentiation of that one is summation, because of it is started from 0. So what you have to do is start from n is equal to 1 to infinity and d dx of x to the power x plus 5 to the power n. Using this rule, n means here n, x to the power x plus 5 to the power n minus 1, sorry, n minus 1 here, not n plus 1, n minus 1 here. So what you have to do, write just n minus 1. N minus 1. This is the answer of that question. N is equal to 1 to infinity n into x plus 1 to this one. This is the answer of that part. I mean power series differentiation by using rule. Now I am going to tell you this one from exercise 6.1. Differentiate term by term by of the following power series. So a part I am going to tell you that fx is given here from n equal to 0 to infinite minus 1 to the power n into x to the power n. So what we have to do, just nothing, just write d dx of f of x equal to summation from, change here because of you are going to differentiate, so it will come 1 minus 1 to the power n and then d dx of x to the power n. Differentiate it. Differentiation of that one is f dash x equal to from summation from 1 to infinity minus 1 to the power n, and differentiation of this one is x into x to the power n minus 1. This is the answer of A part. Similarly, if you want to write the answer of B part, fx is given summation from n equal to 0 to infinity 3 times x minus 1 to the power n divided by 2. So what you have to do, first of all, you have to simplify it. So fx here, summation from n equal to 0 to infinity 3, and see that one, this is x minus 1 to the power n divided by 2 to the power n. So you have to keep outside and put it like that one. So this fx becomes now from n equal to 0 to infinity 3 divided by 2 power n. Why I am writing this one? Because of this n 2 power n is constant term. So you can easily differentiate. So now differentiation of this power series is f dash x. Differentiation of fx is f dash x. Because of you are going to differentiate, as I told you, if it is starting from n is equal to 0, then put it n is equal to 1, this series directly. 3 divided by 2n, this is 2 power n, this is constant term, and then n into x power x minus 1 to the power n minus 1. This is 2 power n. This is 2 power n. So write here 2 power n here. So I'm just writing here because of by mistake I'm writing another term. So write here 2 power n writing here 3 by this. So this is the answer of that question, which is called as differentiation of the power series by using term by term differentiation. So this is about the differentiation term. Now I am going to tell you how to integrate term by term of power series. Integration of power series term by term. Integration of power series. Integration of power series. So as you know that one here I am using integration. So we need to use integration rule here. Power series is same, but we need to use here integration rule. So for that, suppose that if I have this one again from fx function from n equal to 0 to infinity x plus 5 to the power n. If you want to integrate this one, so what you have to do, just integrate this function fx dx means integrate this function. So integration of that one is x plus 5 to the power n plus 1 divided by n plus 1. Finish. This is the answer of that one. Integration of that part is x plus 5 to the power n plus 1 divided by n plus 1. This is the answer of that question. Directly we can use integration rule. Integration of this part is x plus 5 to the power n plus 1 divided by 1. Here limit signal will not change. Just remember that one. Limit signal will not be changed here in this question. Now I am going to tell you how to integrate of power series by using term by term. So this is exercise 6.2. Integrate the following power series. So what we have to do, I am just going to tell you a part. How we can just write it fx terminology and then integrate it. So integration of that means integration of fx dx is nothing but n is equal to 0 to infinity 5 x to the power n plus 1 means you have to add 1 and divided by n plus 1. That means this. So the integration of that part is integration of the power series fx function dx is summation from n is equal to 0 to infinity 5 times x to the power n plus 2 divided by n plus 2. This is the answer of that question. Similarly, you can integrate this one. Integration of this part, b part. So integration of that part, integration of fx dx, summation from n is equal to 0 to infinity x plus 5 to the power n plus 1 divided by n plus 1. Do not write here plus c because you are going to integrate, but because of this is power series, so this n means here when you substitute then constant will come. So no need to write here constant terminology, my dear friend. This is the integration of the power series part, which is given in exercise 6.2. Hopefully you people understand this one. Now I am going to tell you how to check any power series is whether it is convergent or divergent. For that, just if the series is given as, summation from n is equal to 1 to infinity an, then if limit from definite integral from 1 to infinity fx dx converged, if this holds, if it is converged, then the series is converges. If this one is divergent, then series will be divergent. So for that, I just want to tell you few questions from the exercise 6.3. Exercise 6.3, that is this one. Use the integral test series of the following. Which of the following infinite series converge and diverge? So I am picking this question, A part, that is summation from n is equal to 1 to infinity 5 divided by n plus 1. How to check that this series is convergent or divergent? Convergent means when you got any value. Divergent means when you cannot find any definite result. That is called convergent and divergent. So try to check from this one, compare. So here, if I compare from the given series, this you can use as a rule. So if I compare from that, an is equal to, see that one, an means 5 divided by n plus 1. So what we have to do, just check now if this series convergent and divergent according to that rule. So what we have to do, just an, that means now what we have to do, just I am going to check whether this series is convergent or not. So I am going to use this limit, this integral fx, that means change in place of x as n as x, 5 divided by x plus 1 dx. So now when you integrate this one, it is coming 5 ln of x plus 1 and then limit. So when you use the limit, it is coming 5 ln of infinity minus 5 ln of 2. So because of ln of infinity is not defined, so it is divergent. So it is divergent. Similarly, B part, this is A part, B part. That one is from summation 1 to n is equal to 1 to infinity 1 divided by 2n minus 1. Check that whether this is convergent and divergent. So again, what we have to do here, I need again to compare. An is equal to 1 divided by 2n minus 1. Now use this rule. That means if this series is convergent and divergent, then this limit defines like that accordingly. So what is that? Fx dx. So put here 1 to infinity. Fx means 1 divided by 2x means n means here x you have to change. Now integrate it. When you try to integrate, it will come 1 divided by 2 ln of 2x minus 1 and the limit is this. So see that one again, limit, when you substitute limit, it comes infinity. So again it is divergent. So we can choose accordingly, and then we can tell that the question whether is convergent and divergent, and that one is called integral test. This one is called integral test. When you compare by using whether it is divergent or convergent, it is called integral test. Integral test. Why integral test? Because of you are going to use this power function by using integration. If it is converged or if it is diverged of that series by using the integral method. So that's why it is called integral test. Hopefully you people understand about chapter number 6 also.